Hi, I'm Jim Canal, and this is my Module 5 assignment for RSH916 Action Research at Aspen University. The title is Improving AI Course Content with Interactive Visualizations. It's an action research project proposal to improve student understanding in AI courses. So the problem is some courses have concepts that are difficult to learn, especially when the only resource is the printed textbook or academic papers. So the goal of this action research proposal is to improve concept understanding for topics taught in a specific course, Aspen's DSC909 Artificial Intelligence course. The course text is Artificial Intelligence, a Modern Approach by Russell and Norvig, and it includes a lot of examples, but they're all printed. They're not interactive, they're not visualizations. Who's involved? Well, the instructors are certainly involved because they're grading the content of the course. Students are involved because they are actually using the visualizations to understand difficult concepts. The researcher is involved because they are going to observe how and when the interactive visualizations are used and help evaluate the effectiveness of that visualization. School administrators need to be involved because this is an action research study involving students, and there may need to be some changes made to the course content that's delivered on the system. Now, the biggest obstacle is there's no budget. To support this research, we won't be able to use dedicated servers to host interactive visualizations. But we could develop content with JavaScript to run inside the browser without the need to store the data in the cloud. Or we could develop content that could run locally on a personal computer. But this would require developing content for multiple operating systems, and there will be an extra concern for security-conscious users who don't want to download software from a non-professional, untrusted source. Now, if you're wondering what an interactive visualization is like, I developed one for the AI course when I was taking it, and it was a visualization regarding configuration space and workspace in the context of a robotic arm. Now, it's hosted on GitHub right now, and I'll demonstrate how it works. If you navigate there, you get a simple textual description of what's going on. There's some math involved here, and if you read the text, you would kind of understand it, but maybe not really understand it. Down here at the bottom is the actual interactive visualization. So imagine this being the base of a robotic arm. This is the shoulder joint, and this is the elbow joint, and they make up the robotic arm. And we can set it in motion and see how it behaves. Now you notice that it can travel anywhere except the bottom boundary. It just can't get past that. And that's represented in this configuration space. Now, as I can click anywhere in this space, and it will show me the mapping to the workspace up in this region. So I click over here, and this is the position of the arm. Click over here, this is the position of the arm. If I click in this black spot, you'll notice that the position of the arm is where it's not allowed to be. That's because the configuration space has blacked out regions where the arm can't travel. So I'm going to set this thing in motion, and I'm going to add blocks in the space and see how they show up in the configuration space. And you'll notice that the arm can't travel through it either. If I create a block right here that's inside this circle, the shoulder can't get there, and it shows up in the configuration space as a vertical bar. So the student would interact with this, get a feel for what changing the parameters is, what the mapping is. I can change the arm length, I can change the shoulder length, and see how it affects the configuration space. This is an interactive visualization. And this is the kind of stuff that we want to bring to the AI course. Now, I'm not the first person to think about this. About 8 years ago, a GitHub project called Aim at JavaScript was created to organize community-created JavaScript visualizations for this very textbook. Some of the content, interestingly enough, was developed at hackathons. The project became inactive about 6 years ago. I tried to add my own projects, but I didn't receive any response. And to give you an idea of what it might look like, if we go to their site, they have a nice little front page, and every chapter is mentioned here, although some of the chapters really don't have any content. Some of them do. For example, searching, this is the algorithm stuff that I told you where interactive visualizations were applied successfully before. I can click on nodes and see frontier nodes getting developed. This is a visualization of a breadth-first search, which is kind of interesting. Which I find more interesting is this analysis of the shortest path versus the lowest cost path. And you'll see that the nodes traveling are a little bit different. This is the kind of visualization, some of these are out there. They're very simple visualizations, but they really help understand the concept. So, what are we going to do? Well, we're going to start with the hypothesis that providing interactive visualizations of difficult content in the AI course will improve student understanding of the concepts. Now, this means we'll be developing or reusing existing visualizations, and they'll happen gradually over many cycles. Each cycle will focus on one visualization and one concept. And for each of these concepts, we will interview instructors to see if they are aware of any difficulties in the understanding of it, and the visualizations will be developed or reused. When a new visualization is available, instructors can decide whether or not to incorporate it into the course, which is probably will just be a link to content hosted on GitHub. Web pages, like the one I showed you about the JavaScript project, will be provided to make the content easy to navigate. Technical problems will be managed by the GitHub Issues feature. Computer science students should be familiar with GitHub and how to create an issue. Short videos will be created for each visualization, providing both an explanation of the topic and instructions on how to use the visualization. They'll be evaluated by leveraging the quizzes feature on the D2L platform. Quizzes will not contribute to the grade, they merely act as a questionnaire system. And if that's not available, we can provide a questionnaire system embedded into the visualization itself. Leveraging the discussion feature on D2L to engage with students regarding specific visualizations will help connect the researchers to the students again in an interactive, collaborative way. We'll perform interviews with students who have used the visualizations in an attempt to assess their perception of how it might or might not have contributed to their understanding of the concept. And this is all based, and then we do, rinse, lather, repeat. We go on to the next cycle, the next visualization, the next concept. And this is all revolving around this one particular textbook. I have a couple of additional references that I'm just going to throw up here to emphasize that this is not new ground, though most of the visualizations for computer science are been in the algorithm space. Not as many are available in the AI space. So I'd just like to thank you very much for listening to my video, and I hope you got something out of it.